All right, let's look at an expected value question. So let's say you've got a friend looking to borrow some money for some business. They want to borrow 5,000 bucks from you and they offer to pay you back $5,500 in 1 year. That's a 10% payment. That looks pretty decent, right? If your next best alternative is a certificate of deposit, a CD at, say, 2%, that means you're getting basically $400 more by loaning the money to your friend than if you loan the money to the bank. Right? Now, on the other hand, if you loan the money to the bank, that is going to be a very safe investment. Right? So a certificate of deposit, you are definitely going to get paid back. But if you issue a loan to your friend, there is some chance that they go under and they're unable to pay you back. Now we're going to make some simplifying assumptions, right? So first off, we're going to assume that your friend either pays you back or they don't, right? So there's no middle ground. There's no they pay you back some of this. So starting with this basic setup, we want to think comparing the loan option to the CD. We want to think if these two are going to be equivalent, what does that tell us about the risk that we're facing by loaning the money to your friend? And then we'll go the other direction. We'll think if there is some chance of failure, then how far off is this loan from what we really want to see? So let's go ahead and consider this in a spreadsheet. So over here in this column, I've got the safe bet. You give up 5,000 bucks now, but your future value is 5,100, and that gives you a return of 2%, right? You lose 5,000 bucks now, but you get that back plus 2% after 1 year. And then for your friend, we've really got two columns that we want to consider, and then we want to roll them together to get the expected value. So in any case, you are losing $5,000 up front. And I've got 3 copies of that just to make the formulas a little bit simpler. If you get paid back, you're going to get 5,500 bucks, and your return looks like 10% if you are in that column. But if your friend goes under and they don't pay you back, then you're looking at a 100% negative return, right? So 10% up, 100% down. Right? For that to be a sensible thing, we need to think about what are the probabilities that we're in either column. So let's just say we had a 95% chance that your friend pays you back and a 5% chance that they lose money. Your expected value in that case is, your expected future value is $5,225, and that gives you a return of 4.5%. Now, this is getting us closer to the question in the second part. And actually, I'm seeing now that that 5% is maybe a little bit low. So maybe we change this to a 25% chance. And I'll update that on Blackboard also. All right, so what does this look like if there's a 25% chance? Well, that means there's a 75% chance that you get paid back. And for those numbers, on average, you're getting paid back $4,125. So if you imagine that you had a bunch of friends asking for these loans and they're all sort of equivalent in some way, then on average of these loans, you either get paid back or you don't, but on average, every 5,000 you put in, you get back 4,100 for a return of negative 18%, which really sucks. So for that second part, we're going to ask, well, what if we add in collateral? But let's get to that when we get to it. We'll start with asking, what do we think the probability is that they fail if the expected value, essentially if this number is equivalent to this number? So let's try and use Solver for this. So what is our target? Let's go ahead and set our target to be this cell, and we're going to give it a value that is 5,100, and we're going to change this cell in order to do it. And let's just, to be safe, say that this cell has to be less than or equal to 1, and it also has to be greater than or equal to 0. So this might be kind of hard to see if you're watching this video on a phone, but there's an equivalent thing in Excel. It's called Solver. Ask Google how to set it up, but we're saying, let's set our target. Let's solve this problem so that it gets a value of 5,100 by changing the probability that your friend actually pays you back. So let's see what happens. We run solve, we will keep results. This is saying there is about a 93% chance that they pay you back if, in fact, their offer of a 10% interest rate is in risk-adjusted returns equivalent to your next best alternative, your safe bet. So our question said, assuming this loan to your friend has a risk-adjusted return equivalent to the CD, right? So this return, where we're saying you are losing $5,000 up front and you expect to get 5,100 back, you don't actually expect to get 5,100 back, right? You're either going to get 55 or 0, but your average or probability weighted average return is 5,100. And that would be the case if there is a 92.7272727% chance that your friend is able to pay you back. So how do we find that? Well, I got, in this case, LibreOffice to do the hard work. But we could have also just said, well, let's start with, say, 50% chance they fail. Well, that's way too high. You're losing money. Let's try 75%. That's still too high. Let's try 87%. Still too high. 95. Okay, now our return is too high, so our chance of failure is actually too low. And so, what do we set? We said 92, right? So if we go to 90%, we're getting negative. If we go 925, we're getting pretty close, right? So the way to solve this without using Solver is to just kind of plug and chug, try different things. You can see this is not too far off. So 0.927 gets us almost there. We need just a little bit more. All right, so this is kind of within the rounding error. Make that 0.928. That's also pretty close. Either of those options, frankly, good enough for this class. If you're working for a bank, things are a little bit different. But solve that problem when you come to it. All right, so if your friend's business, if this loan your friend is asking for is equivalent, is risk-adjusted about as good as the certificate of deposit, it must be the case that their chance of failure is about 93%. But what if that is not really the case? What if there's actually, say, a 25% chance of failure? All right, so that would mean 0.75 here. And in this case, this means that on average, we are in a situation where we're losing money. So now we're going to add in the possibility of collateral, right? So if your friend doesn't pay you back, now they've got to give you their car, right? And we'll assume, we're going to simplify. Let's assume that they're not going to trash their car, what will be your car. Let's just, sort of assume some nice thing. Let's not worry about the extra layers of complexity that come into dealing with particular assets. That's just some collateral that's worth some amount of money. Right? And let's just think about what it's going to be worth to you. So if they give you their car and you can sell that car pretty easily for $2,000, in this case, you're still losing money, but you're doing a much better job. So let's, just to clarify what cell we're changing, let's highlight this guy. Let's use Solver again. So now, what do we want to do? We still want to have the same expected value, but now we're going to be changing this cell. And this, we don't want to be less than 1. We do want it to be greater than 0. I say D7, let's make this D6. So D6 definitely should be greater than or equal to 0. And you know what? I don't even need this first one. We're just going to have some positive collateral. So let's go ahead and hit solve and see how much collateral do they need to put up. 3,900. So what this means is if they succeed, their business works out, and they pay you back the $5,500 they promised, you're doing great. But there is a 25% chance that they aren't able to pay you back. But if they give you their car, and their car is worth $3,900 to you, then we are now in a situation where that loan is equivalent, right? Now, you're not likely to ask collateral from your friend, but if you are running a bank issuing loans to strangers, well, having this collateral means that you can give them this loan at 10%, and you can feel good about not losing money, right? So remember, if this is 0, then on average, if you issue a bunch of these loans, you're just not going to be making enough money to keep your doors open. Your bank is going to go out of business. Let's try one other version of this. Let's change the interest rate. So we'll keep with 0 collateral, and we will keep with a 25% chance of failure, and that's still going to be greater than or equal to 0. Let's see what we get. No solution found. Well, that's not good. Target cell. E6 to have the same value as B6 by changing the cell C8. C8, that's right. You know what? C8 is not something that we are changing. So actually, we're going to change this one. C6. There we go. All right. Now let's solve. Keep result. Okay, so if we don't have collateral, how much do we get paid? Oh, you know what? Let's copy this over here just so we're getting a better calculation. So without collateral, right, you're issuing a loan not to a friend, but to some stranger. And you need to make sure that this loan does about as good as the safe bet. You want to be making more, but you don't want to be making so much more that this stranger goes to the bank across the street. So let's just look for equivalence, right? So where is this loan to the stranger equivalent to the safe bet? And let's just assume that as the bank, you can also get something like this 2% return. In that case, if it's something where you can't get collateral, like say giving them a credit card that they can use to buy lunch, if you're giving them $5,000 that they're going to be spending and you can't get anything back from them, and there is a 25% chance that they don't pay you back and a 75% chance that they pay you back with interest, how much interest do you need to charge? Well, in that case, 36%. 36% is enough that when they pay you back $6,800, the 3/4 of your loans that pay back offset the 1/4 of your loans where you lose $5,000. And the net effect is that over these loans, you are getting the equivalent of just making that safe bet. All right, let's take a look at what we've got in all of our formulas and then explain what we just saw. So you can pause and copy these into your spreadsheet if you'd like. But let's see basically what we were looking at. So we start with the safe bet, right? We're saying there's a 100% chance that we get this future value, and given that future value, our return is 2%. If we've got this loan to our friend, we've really got these 3 cells we considered changing. Let's make these different colors just to make them stand out. So we started by thinking about the blue cell. And there we were asking for a $5,500 payout, a 10% loan. Make these a little narrower so we can fit them all on the screen. For that 10% loan, what must the probability of success be? And it was something like that. At that point, let's add another 7 there. At that point, if there's a 93% chance that your friend is able to pay you back, then the loan at a 10% interest rate is equivalent to the safe bet. They have the same expected value. So there we've got two expected values, and we've got an unknown, which is the probability that we're in this column versus this column. So there we're just solving for that probability to make this equivalent to that. All right, so that was the blue sum. Then we said, all right, well, what if there is some specific number there? Can we change this number? And what did we say? 3,900? At 3,900, changing the yellow cell, we are basically changing what is our worst case scenario. If our worst case scenario is 3,900 instead of 0, now we've got an equivalent for this much less favorable probability. And then we go back to the question of, well, let's say we have some other level of collateral. Let's try one more. Let's say we've got a level of collateral of $1,000. So your friend says, hey, I've got this collector's baseball card, and you could sell it for, $1,100. Call it $100 for the value of your time actually trying to get this thing sold. So you've got collateral worth $1,000. Right? That's still not enough to make the loan equivalent. Then the question is, how do we adjust that interest rate so that we are getting that expected return equivalent to our safe bet? Actually, we changed this one and then recalculated that, but they're going to be equivalent. Right? So let's go ahead and just show it in this form. We will solve here. So what this means is this is going to be the absolute value of our loan times 1 plus our return. And our return 0.1, there we go. So now we can change this. Before we were using solver to change how much we get paid back. Now we're going to change this one, but it should give us the equivalent. And let's just see what happens if we don't do anything. 5,100, is that right? Oh yeah, sorry, this is with 1,000. So with more collateral, our return, our interest rate we have to charge falls. Right? If we make that 0, let's try it again. I don't think we need to change anything in solver, so let's just hit solve. 36%, we're getting paid $6,800 on that $0 collateral. So 1/4 of the time we lose a bunch of money. 3/4 of the time we make a 36% return on our investment. But because we're losing so much, our risk-adjusted return is still equivalent to what we had there. All right, so all of this expected value, let's just really quickly lay out what this is. Our expected value fundamentally is probability of outcome 1 times the value of outcome 1 plus the probability of outcome 2 times the probability of outcome 2, and so on for any number of possible outcomes. In this case, we were just considering 2. Right? So the thing to be aware of here is all of these p-values have to add up to 1. Right? In this case, I set that up to say the probability that we lose money is just 1 minus the probability that we make money. So we're taking those probabilities and we're multiplying those by the outcomes. And so in this case, you can see right there, probability times outcome plus probability times outcome. When we change those outcomes by adding collateral, we can change the interest and keep something roughly equivalent. And hey, super nice. Under tools, we can use solver to get Excel to do this. But of course, you can also just do this with good old-fashioned algebra. But since this video is already 20 minutes long, I'm going to skip that. We can talk about it in class. All right. I hope that was helpful. As usual, feel free to ask questions in all the usual places.